Today we're looking at the general case of arc z minus z1 on arc z minus z2 equals theta. And generally, basically, there are 4 cases for this. And oh, by the way, theta is not 0 and theta is not equals plus minus pi, which are subject to separate videos. Here, theta is not 0 and theta is not plus or minus pi. And theta is basically none of these, but theta can be positive or negative. And so you have to know the basic theory first of the argument. So this relies on a geometry theory that is this. It's actually rely on this theory that is in geometry. So you have here your theta, you have here your alpha, and you have here your gamma. So basically, gamma is equal to alpha plus theta, because the theory says that the exterior angle of a triangle is equal to the sum of the 2 opposite interior angles. And so when you rearrange that, you get gamma minus alpha equals theta. So keep that in mind, because what that is going to be applied to this theory over here. Also recap as well, arc z minus z1, very important you know this definition, is that you look at this from vector perspective. This, inside the bracket, is actually a vector from z1 to z. And arc z minus z1 is actually the angle that the vector from z1 to z makes with the positive direction of the x-axis. So I'll say that again. This is shorthand. So arc z minus z1 is the angle that the vector from z1 to z makes with the positive direction of the x-axis. Likewise, arc z minus z2 would be the angle that the vector from z2 to z makes with the positive direction of the x-axis. So what do you have then? Okay, so first case, theta is greater than 0 and theta is acute, let's say. All right, that's case, the subcase number 1 of number 5, so case A. So this is case A. So how did that work? Well, for all intended purposes, I'm going to make Z1 and Z2 completely flat. In other words, the interval joining that, so that's your Z1, that's your Z2, completely flat. In there, you see they normally put on the x-axis, all right? But I'm going to make it flat, and I'll show you when it's non-flat, it works as well. And if it's acute, then basically these all form arcs, by the way. When it's not 0 or positive negative pi, it's going to be an arc. It's a matter of whether it's a major arc or minor arc. Now, major arc, by the way, incidentally, is this. This is your minor arc, the top bit, and this bit down the bottom here is your major arc. So this bit is a minor arc, and this bit is a major arc. It's a bigger arc, of course. So we say this is acute. So acute means it's going to be a major arc. Why is that? I'll show you. Major arc, my drawing looks like that. And then the other part is the small one. Now that it's like an egg, but I pretend that's a circle, right? So that angle there is referring to this angle here. And I'll show you how. And this is where, very important, you know, the definition of what I just went through. So you treat it as a vector. So vector from Z1 to Z is actually that vector there. And the vector from Z2 to Z, that's vector there. And then when you use the definition of arc of Z1 minus Z minus Z1 rather, so there's your Z1, there's your Z, by the way, Z lies on that. So this angle here, by definition that I just went through, let's call it gamma. So this guy here then is gamma, according to definition, because that says that is the angle from Z1 to Z making with the positive direction of the x-axis. And that's arc Z minus Z1. What is arc Z minus Z2? Well, that would be the angle that this vector from Z2 to Z make with the positive direction of the x-axis, which is this angle here, and I'll call it alpha here. And if you look at that, so alpha then is arc z minus z2 by definition. Because angle that the vector makes, the vector from z2 to z makes with the positive direction of the x-axis. So if you look at the triangle here, which is that theory that we had, isn't that mean that gamma minus alpha equals theta from our triangle that we proved above? Because exterior angle of triangle is the sum of the two opposite interior angles. So when you add it up and take the alpha to the other side, you get this. But hang on, but gamma is that guy there. So that's arc z minus z1 minus arc z minus z2 equals theta. Now, when you have a minus, basically, you're going to divide, because that's a theory about complex numbers, isn't it? When you divide, that means you minus. So the arc of a division, arc of a quotient, is the difference between the individual arcs. And voila, that is an arc. That's why the answer is an arc, for that reason. So I'm trying to fit everything in here so you can see the whole lot, right? But this theory, in this case, is that it's a major arc, in fact, when the angle is acute. All right, so that's the theory. So when theta is acute, then it's a major arc. And I'll show you another video where it's a minor arc and where it's on the bottom as well. So I'll stop there for this case.